In the previous videos, we add two-dimensional vectors by getting its components with respect to the axis where it lies. In this video, wherein we are now dealing with three-dimensional forces, the technique is not different from the technique we use in 2D. We are still considering a force taking its components with respect to the axis it lies. But this time, kung katong sa una, it's only 2D, the XY plane. Now, we are dealing now with the third axis, which is the Z axis. So all in all, we have three-dimensional because it's already XYZ plane. So to solve the components of a force, there are three, I guess, method to solve the Fx, Fy, and Fz of a force. And number one is what we call blue triangle method. To solve for Fx, Fy, and Fz for blue triangle method, we have these formulas. So unsa man ning theta z og phi? The theta z is the angle between the z axis to the force. Let's say kani nga 180 Newton force. So let's say this is the z axis. Theta z is this angle. The angle from the positive z axis to the force. And the phi is the angle between this phi is the angle between the positive x axis. See, this is the x axis. Positive x axis towards the force. Something like that. That's it. And the third one, we got directional cosines. For directional cosine, to get its fx, fy, and fz, it's pretty straightforward. Just multiply f times cosine theta x, then f cosine theta y for fy, then f cos theta z for fz. So what are these theta z, theta x, and theta y? Theta x is the angle between, let's take for example this force, the angle between the x-axis to the force, that's the theta x. And for theta y, of course, it's just the angle between the y-axis towards the force, this one, and then theta z, the angle between the z-axis, positive z-axis to the force. So that's it. And the third and last one, the lambda method. To use this lambda method, we just have to consider this vector and then get its magnitude. This notation here, the absolute value means the magnitude of the force multiplied by the lambda. Now the lambda is the what we call directional vector because it's in IJK form. In this first two approach, we're given with the angles. In this third one, we're given with the direction, how many to the x, how many to the y, or how many to the z. Kung sa 2D pa na siya, that's the slope triangle. Pero dire kay 3D man, that's marag cube. Just like here, we have in the F3, which is 320 pounds, let's say, newtons. Na siya ikan, 4 in the y, 2 in the positive z, positive x, and then 1.5 in the negative z, because z is positive here. So with that, we just have to get this 320 newtons and multiply to the lambda, which is how many in the x plus how many in the y, or minus how many to the z since it's going downwards, divided by 4 squared plus 2 squared times 1.5 squared. So to understand more about this, let's solve this problem. For the first force, which is 200 newtons, F1, we cannot use their lambda method because we're given with the angle. So we can choose if it's directional cosine only, or blue triangle method. And since what we have here is the angle between z and the force, and the angle between negative x or negative y to the force, what do you suggest? I think it's blue triangle because I have the angle phi, which is the angle between the positive x and then the force. And by the way, phi could only be positive if it's going counterclockwise. But if it's going clockwise, that's negative. This is now negative. So since we were given with 30 here, and the angle or the complementary angle of 30 is 60, therefore this phi here is negative 60. That's what we're going to use. And then the theta z is 30 degrees, is positive z towards the force. So with that information, we can now solve for fx, fy, fz by substituting to this formula. F sine theta z cos phi. So what we have here is 200 newtons times, that's the force, this F sine theta z cos phi. So we have sine of theta z, which is negative 60. I mean positive 30. Theta z, this is theta z. This is positive 30 multiplied by the cosine of, this is now negative. Negative phi. Negative 60. And boom, we got the fx. This is fx of force 1. Fx of force 1. Then for the fy of force 1, or the first force, we have f sine of theta z times sine of p. So what's theta z? We know theta z is 30 and the force is 200. Then sine 30 and then sine of negative 60. So that's it. Pretty straightforward. We just have to substitute to the formula. And then for fz, we have f cos theta z only. So we will have 200 times cosine of 30 degrees. So that's it. This is how we got the components of the forces in 3D. So now we have this answer. For Fx, it's 50 newtons. So just a quick check. Since this is positive, it should be the Fx going positive. So it's correct since our force is heading towards positive x, this force. And then negative 50 square root of 3 in the y. So this is positive here. And since our force is going to the opposite, it's negative. So that's negative. Correct. And then for z, it's going upwards. So also that's positive. So if we recheck this, it should be equal to 200 if we get the resultant of this. So just like having 50 squared plus 50 square root of 3 squared plus 100 square root of 3 squared. So that's it. It's equal to 200. So we're correct with our components. And the second force, which is F2 equals 180 newtons, we're given with angles between the force and the x-axis, the force and the y-axis, and then the force and the z-axis. Therefore, we can use this second method, which is the directional cosines, because we're given with theta x, theta y, and theta z. So we just have to plug that into the formula, and what we're gonna get is f cos theta x. So f is 180 times cosine of theta x is 120, this axis to the force. You can see that. That's cos 120. And then we got the answer for the force in the x. And then for fy, it's just f cos theta y. This is the directional cosine. So cos theta y is the angle from the y-axis to the force. So we're given with 60 degrees. So just put that 60 degrees. Then get the value. Then for fz, it's f cos theta z. Theta z. So we have 180 times cosine of what we have here is 45 degrees. So now we got fx, fy, and fz of force 2. So these are the values. Of course, you always have to check it if it matches to the force. Since we just break this force to its component, the fx, fy, and fz, it should match to the direction. So the fx we have here is heading towards negative x. So it's correct. It's heading towards the negative x, and then for y, going to the right. So positive, and then positive z, it's going upwards. So we're all we got correct answers here. That, and then check the values if it goes back to, kung mabalik ba siya sa the force, which is 180. So if we try it, 90 squared plus 90 squared plus 90 square root of 2 squared, square root of 2 squared, so it's 180. So our force here is 180. So we're done with force number 2, is F2. And then for the last force, which is F3, same thing. I-break down na nato siya into its components x, y, z. But this time we're given with dimensions 4, 2, and 1.5, and not the angles. So this is the perfect time to use lambda method, in which we have F3 is equal to F, the magnitude of the force, times the lambda. So sa maning lambda? Let's start with force. This is 320. And then the lambda, what's lambda here? How many in the x? It's positive 2. So we have 2i. And then for the y, it's still positive, but this time it's 4 plus 4j. And then as you can see, it's going down, so it's negative because positive is going up in the z direction. It's minus 1.5 k hat all over the square root and the square of that. What's in here, you just copy that. 2 square plus 4 squared plus 1.5 squared. Daghan na po dahil tuldok. Plus 1.5 squared. So now we have, para mas klaro, for the x we have 320 times 2 over square root of 2 squared plus 4 squared plus 1.5 squared. This is the magnitude of the force going towards the positive x direction. Then plus 320 times 4 over the denominator. 320 times 4 all over 2 squared plus 4 squared, 1.5 squared. Just like that. And pagamayan sa nato gamay para maluon. Plus the z, which is it's actually minus because that's negative 1.5 minus 320 times 1.5 all over the denominator squared plus 1.5 squared k hat. So that's it. This is the x component. This is the y component. That is actually has j hat. And then this is the z component. And now adding all reds, all greens, and all blues. For all reds, we will have, that's the summation of forces x. And then for all greens, the summation of forces y. And then for all sky blues, summation of forces z. And to get the resultant, the magnitude is the square root of summation of forces x squared plus summation of forces y squared plus summation of forces z squared. So that's the magnitude. And to get the direction, we just use these formulas. Cos theta x is equal to fx over the f. And we already have this fx. And this f here is talking about this resultant magnitude. So we can change this f to r. So rx over r, the resultant. Then for cos theta y, or the angle with respect to y-axis, it's ry over r. And then cos theta z is rz over r. And thus we have theta x, theta y, and theta z. So let's get the values now. So after adding all the reds, this 50, negative 90, and this value here, I get 95.68. And then for all greens, this negative 50 square root of 3, this 90, and this value here, which are all the y's, or the sum of the forces in the y direction, I got 274.76. And then for the z, which is the blues, this, I got 198.72. And plugging that all of this to the formula, fx, fy squared, and fz squared, and taking the square root, I got the resultant magnitude, which is 352.33. And then since I already have this rx, this one, and the resultant, which is 352, I substitute that in this formula, take the cos inverse, and that's now the theta x, and repeat the procedure for theta y and theta z. So now the final answer, if I add all these forces in 3D form, 180, 200, and 320, is now this one. 352.33 is the magnitude of the resultant, located 74.24 from the positive x-axis, 38.76 degrees from the y-axis, and 55.67 degrees for the theta z, or the z-axis. So that's it to solve this one. So the very lesson here you need to remember always is how to use these methods: blue triangle method, directional cosines, and lambda method. You use lambda method if the forces and the direction given to it is the length or the magnitude, just like this one. It's given in 4 meters, 2 meters, how much in the x, how much in the y, and how much in the z. So that's lambda. And if the given is in theta x, theta y, and theta z, all three angles, you can use directional cosines. And if the given is only two angles, the angle in the base, or the phi, the angle between the force and the positive x, you use blue triangle method. So that's it for this video, and I hope you learned something, because it's a very long video to explain, because of course 3D force, makalibog yun siya tinuod, may daghang forces nga, daghang components i-consider. But if you master this one in adding vectors in 3D form, you can always practice ra gyud. So salamat, that's all for this video. Thanks for watching, peace out.